So we have to simplify. When we add and subtract radicals, they have to have the same what? Radicand. Yes, you are right. You didn't guess it, you knew. It was internal. That's an equation.
Yo, you just swear at me because I got the answer right. Like, you need to chill.
Right. So we have -1 plus 2, which is 1 root 13, and I don't have to write the 1 in front, but I can. But I'm not going to. Okay, this one, I do 4 minus 2, and people will try and subtract them. Can I subtract them right now? No. But the root 112, what can I reduce it by?
16 and 7.
16 and 7. And I can take the 16 out.
Sorry, I actually didn't mean to do that. I was trying to...
All right, so then we have 4 root 7 minus 8 root 7, which is -4 root 7. Boom. Okay, cube roots. We have -3 equals negative cube root of 3 plus, and then the cube root of 24 I can break down into what? 8 and 3, and the 8 comes out and becomes a 2. So we get negative cube root of 3 plus 2 cube root of 3, which equals -1 plus 2 is 1, so I don't have to write the 1, but if you want to, you can. So it's cube root of 3. Okay, now we get to variables, which I told you is going to be in the curriculum, right? They had variables. Rylan is dancing it out. This class is getting out of control. You want to show the class? Or? Okay. All right. So, 45, I can break down into what? 9 and 5. Good answer. Thanks, guys. 9 and 5. And then we have an x cubed, which we could draw as 3 x's, right? The 9 comes out and it becomes a 3. And then I can take 2 x's out for 1, so I get a 3x out here. That cancels. And I'm just going to write it down in the next step before I move on, because it's all smushy. So 4 times 3 is 12x, root 5x. 27 I can break down into 9 and 3x. The 9 comes out and it becomes a 3. So I get -3 root 3x. Then 17 root 3x is done. And then 125 I can break down into what? 25 and 5. Good job. 25 times 5, x, x, x. Okay, so 25 comes out and it's a 5. And then 2x is for 1. So we get -45x root 5x. Now there's 2 terms that have a root 5x and 2 terms that have a root 3x, so you should be happy with yourself because it looks like it's probably correct. And then we math it. So 12x minus 45x is -30.
You're talking about math.
Girl, please. -33x 5x. And then -3 plus 17 is 14 root 3x. Okay. 44, what can I break that down into? 4 and 11. The 4 comes down and it becomes a 2. And so we get 2 times, it's 2 over 1, right? So 2 times 2 is 4, 5 times 1 is 5. So I get 4 over 5 root 11a. 144 actually just comes out as a 12. The square root of 144 is 12. So we get 12a root a. And then minus root 11a. Now when it's divided by 2, how else can we write it instead of division of 2, which looks confusing? Multiply by a half. So I can write, if I write something like this, a over 2, this has nothing to do with this question, say I did a over 2, I could actually write this as 1/2 a. It's the same thing. So if I have a division of 2, I'm going to bring it in front and make it -1/2. So you guys remember you can bring stuff into fractions, but you forget that you can take it back out. Okay? Now, 4/5 minus 1/2. I need a common denominator, so I'm going to multiply by 5. Multiply by 2. So I get 8/10 minus 5/10, which is 3/10. So I get 3/10 root 11a plus 12a/a. One of the hardest ones I could give you, right? That's a hard one. I found it hard, it's for a reason. It's a hard one. Then what I told you with multiplication, I said if you can reduce first, I would go and do that. If you don't, you can. You can just go ahead and not reduce it, but you're going to be dealing with larger numbers that you're going to have to break down, right? That was the difference. So root 2 and root 6 I can't reduce anymore. So my first step is to check I can't. Then it's coefficient times coefficient, radicand times radicand. So 3 times 4 is 12, and then root 2 times 6, which is 12. The 12 I can break down into what? 4 and 3. The 4 comes out as a 2, and I have 24 root 3. I don't know what just happened there. Okay. The next one, I can break the 15, this is a number. I can break the 15 up into what numbers? Trick question. 5 and 3, 1 and 15, both are useless, so nothing, right? But the f squared, I can bring out as a f. So I can go negative 3f root 15. The 20 I can break down into 4 and 5. And the f6 I can take out as a 3, right? So 2f cubed. So that's gone, and that's gone. I'm going to rewrite it. I'm not going to try and do math from here. That's just awful. So I have equal signs. Negative 3f root 15. And then 2f cubed root 5. Now I can multiply coefficient times coefficient, radicand times radicand. And if I have two bases and two exponents, I add exponents, right? So in the front, I'm going to get negative 3 times 2, which is negative 6. F1 times F3 is F4, right? You add exponents. And then root 15 times root 5. 15 times 5 is 60. Can 60 break down? It's 75. No one speaks up, just these two. Double checking their math because I'm stupid. Yep, you're right, 75. Oh, it's going to be large. 15 times 4 is for sure 60. 15 times 2 is 30, and 30 and 30 is 60. 75 breaks down into 25 and 3. The 25 comes out and it's a 5. So I'm going to get negative 30 F4 root 3. Pardon? As long as you have the same answer, some people will multiply first, which is fine, and then they just have bigger simplifying to do.
Well, I did all the simplifying, and then I went and added the F's and I just kept it under the square root.
And then you took it out? Yep. Same thing. There's a few different ways you can do it. You can choose to simplify the variables or leave it until the end. It doesn't matter. As long as you have the same answer as me and you work your way through, we're good. Yeah. I am not picky on steps have to be the exact same as mine because that's not real math. Okay? Now here, if it's like fake math in the middle and you get the same answer, that's not good either. Like some people like doctor their math and I can see you. Don't do that. Okay. Now, 8 or 18, can I break them down into any 4 root thingies? 4 roots? If that's overwhelming, just multiply them first. So go 3, 4th root. What's 18 times 8? 144. And then 144, can I break it down into any 4? 36 and 4. And 36, and you take it out as a what? No, it's a 4th root. Yeah. Yes, because this isn't going to work. That's a square root number. 16 and what? 9. 16 comes out and it's a 2. So we get 6, 4 through 9. You have to make a 4th column, right? You have to make a squared, and then a cubed, and then a 4. The good thing about once you get to the 4th table, you need to get like to 2, 4, 3 to the 4, 4 to the 4, and stop, because then the number's already really large. Okay, I'm going to get you to flip to your notes where we left off yesterday. Which is here. Task 2. Okay, so we're still at task number 2, but if I gave this to you last year in grade 10, if I gave you 3x bracket x plus 2, and your teacher asked you to simplify or expand, in this case, what do you have to do? Distribute, exactly. So, we would have to, okay, so we're going to have to distribute in, right? And we would get 3x squared. And then we distribute in again, and we get plus 6x. We agree with that? That's all we're going to do for the next task, except it has radicals. Don't move quickly. It's fine. We have all day.
Oh, shoot.
Today was brought to you by the letter D for David. He's shining light today. Okay, I am proud of that. Okay, task number 2. Simplify each expression. This requires some distribution. Identify the restrictions on the variable when necessary. Okay, so we're going to go. If you want to, if there's places where you can reduce them first, you can, just like we did in the previous multiplication. If not, we're going to multiply. So there isn't on these ones. So we go root 10 times 2 root 10. Root 10 is just 1 root 10. It's the same thing, right? We get an equal sign. So 1 times 2 is 2. What's root 10 times root 10? 10. Some people say root 100, which is still 10. Remember that rule when we multiply 2 radicals that are the same together, it just becomes a number? Right? If you do that, you will make less mistakes. So root 10 times root 10 is a 10. And they just end up multiplying. Follow me? Does that make sense? 1 times 2 is 2. Root 10 times root 10 is 10. And we just distributed the first one. Now we're going to distribute the next one. 1 times 1 is 1. I don't need to write 1, but I'm going to for effect. And then root 10 times root 5 is root 50. Our last step always is to simplify. So remember grade 10 simplifying? It's never leaving this whole unit. You're going to have to simplify at the very end of every question. So we're going to get 20, 2 times 10, and then root 50 breaks down into 25 and 2, so that becomes 5 root 2, which people were giving me as answers. So we get 20 plus 5 root 2. Guess what? I've taught you nothing new. You knew distribution from grade 10. You knew multiplication from yesterday. You knew how to reduce from grade 10. I've taught you nothing new. Nothing new. Right? So since I haven't, try the next 3. Try and work through them. So for this one, we're going to go 1 times 3, which is 3, root 15 times 5, which is 75, which I screwed up before, minus root 15 times 3, root 45. Now, 75 breaks down into 25 times 3. The 25 comes out as a 5. So I get 15 root 3. 45 breaks down into 9 and 5. The 9 comes out as a 3. And it's minus 3 root 5. Can I put these together? No. One's a root 3, one's a root 5. Can't add or subtract anything that has different radicands, right? B. 2 root 2 times 1. Anything times 1 is what? Itself. It's what brings you grade 2 and grade 4 when you start multiplication facts. Anything times 1 is itself. So we get 2 root 2. And then 2 times 1, I guess starting with grade 3, gotcha. 2 times 1 is 2. And then root 2 times root 2 is 2, right? You could write root 4, which is 2. Same thing, right? I just find that if people write root 4, they break it down to root 2, and it's not right. So root 2 times root 2 is 2, so it just becomes a 2 here. So I get 2 root 2 plus 4. Now this one has a square root, an x under the square root. The moment it has an x under the square root, I have to say x has to be greater than or equal to what? 0, because it can't be negative, right? It's a restriction. And then we can multiply. 3 times 2 is 6. What's root x times root x? Root x squared, which is just x. Or we can say, hey, it's root x times root x. What happens when I multiply two roots that are the same? I just get the x, right? So root x times root x, just get a bracket with the x. So whenever you multiply two radicals that are the same together, you get them in brackets, just the number without the radical sign, right? And then 3 times negative 1 is negative 3. And then root x times 2 is 2x. So I get 6x minus 3 root 2x, and I can't go any simpler because I don't have like radicals. The last thing we're going to go over is only hard if you forget foiling. So I'm going to go ahead one page. You're just going to pay attention. So last year in grade 10, you were taught if you had like x plus 2 times 2x plus 3, when you had a binomial times a binomial, it's the same thing with the previous one. I have to distribute everything from the front bracket or in front of the bracket to the bracket, right? Everything just needs to multiply by everything. That's the rules when you have brackets. So here, this has brackets, right? They're touching, so it means multiplication. So everything in this bracket needs to get multiplied by everything in this bracket. And you could do it randomly out of order if you wanted to. But last year you were taught an acronym, FOIL. So you did the first, then the outers, then the inners, then the lasts. And you only use FOIL when you have two terms and two terms. Okay? So, for your own benefit, if you want to write it somewhere on that page, if you forget from last year, it's first, what's first in the brackets and multiply together, what's on the outside of the brackets and multiply together, what terms are on the inside of the brackets and multiply together, and what's last and multiply together. Now you could do it without foiling, but if you use FOIL, you will know that you will just multiply everything that you need to. It only works when you have a binomial times a binomial, so something with two terms times something with two terms. We didn't use it in the previous one because we had a monomial, one term times a binomial, right? So we just distributed. So you could do this out of order. You could do outside, inside, last, front, whatever. But then there's a chance you might miss something, right? So that's why the teacher teaches FOIL, because then you're in a proper order. So x times 2x would have gotten me 2x squared. So first times first, then outside times outside. So the outside ones, 3 times x, which is 3x. Then inside times inside, 2 times 2x is 4x. And then the last terms in each bracket, 2 times 3, which is 6. So it's just a method to get all of them to multiply by each other. That's it, right? So the first ones the ones on the outside together, the ones on the inside of the brackets together, and then the last ones on each bracket together. So that's when you have a binomial times a binomial, right? That's literally the only new rule, which is not new, it's from last year, that we're going to use in the next question. Because in the previous example, we had a monomial times a binomial. In this one, we're going to have a binomial times a binomial. So let's look. So I have two terms because there's a plus sign in between. So that's one term, binomial, and one term, binomial. So when I have a binomial times a binomial, I can FOIL. Okay? So I'm going to do first. So the F, first. So the ones that are first in both brackets. So 3 times 5 root 7. What's that? 3 times 5 is 15, and then root 7. So this is why I told you that the multiplication yesterday was so important, because you can't multiply, it doesn't matter if you can FOIL, right? You're going to get wrong answers. So we did first times first. Now O in the FOIL part. So the outside terms. So I'm going to do 3 times 2, which is a nice number. It's 6. Right? Then I'm going to do 4 root 7 times 5 root 7, the inside ones. So 4 times 5 is 20. And here's that trick again. Root 7 times root 7 is 7. I just replace it with brackets and a 7, right? So root 7 times root 7 becomes a bracketed 7, right? So we did first terms, we did outer terms, we did inner terms, and now we're left with the L, which are the last ones in each bracket. 4 times 2 is 8 root 7. So now I'm going to get 15 root 7 plus 6 plus 140 plus 8 root 7. Am I done? My last steps are always to collect like terms if you can. This is why we taught adding and subtracting beforehand, because you're going to have to add and subtract these, right? And we taught simplifying because you might have to simplify. You won't have to for these ones, but you might have to. So 15 root 7 plus 8 root 7 is 23 root 7. I can put them together because they have like radicands. And then 6 plus 140 is positive 146. Next, we're going to go to the tries right below. We're going to do this one together. What does that squared mean? It means it multiply. It means I have 2 of them, right? So when I get a squared outside, I immediately do this. No, thank you. I don't like you there. And then I just rewrite it again. So is it any harder than the previous question? No. You just have to spot that when you have the squared, you have to rewrite it again and then FOIL. Okay? You try this one out. See what you get. So we do first times first. 4 times 4 is 16. And root 3 times root 3 is 3 in brackets. Plus outside times outside. 4 times 3 is 12. Root 3 times root 5 is root 15. Then the inside ones. 3 times 4 is 12. Root 5 times root 3 is root 15. And then the last ones. 3 times 3 is 9. And root 5 times root 5, it's just 5 in brackets, right? When we multiply those same roots together. 16 times 3 is 48. Plus 12 root 15 plus 12 root 15, I can put them together because they have the same radicands, right? So 24 root 15. And then 9 times 5 is 45. And then these are like terms. I can put them together. 45 plus 45 is 90 plus 3 more is 93. And I don't have to state any restrictions because there still was no variables here, right? your homework. Same page as yesterday. So it's page 289. Number 2, BD. Actually, that's line. Number 2, BC. Three, CD. Number 4, CD. Number 5, BD.